Okay, hi, my name's Jimmy. I know all of you, and for some reason, whenever I give a STEM presentation, I'm always sick, so let's just continue. So my project is the effective use of waste energy to convert water to hydrogen fuel. So my technical question is it possible to engineer a fuel cell that has the ability to convert waste into hydrogen fuel at a higher efficiency than 18%? Can it be stored in a lithium-ion battery? So there's a little bit, the fact that this is an engineering project, it's not going to have any independent variables like that, or kind of a hypothesis that is kind of included in the testing question, so don't mark me down. Okay. So let's see, the academic area that I really am interested in, specifically for IJAS, would be environmental science, just because of the impact of it. There's a lot of chemistry that's involved, also a lot of just engineering, because you're kind of designing a new process. So, but the ultimate impact is for environmental purposes. If you've ever taken environmental science, you know that it always involves some kind of chemistry, or because you need to know content of soil or whatever. So, but that's the most important fact, is that it's part of that part. So the mentors I have, her name is Amelia Dar. She's a professor of biological and chemical sciences / engineering at Illinois Institute of Technology. Specifically for the chemistry aspect, I meet with a few other mentors that I've actually got a response yesterday. I've updated this since then. And I might just ask Krexos. I mean, he knows everything. And I actually have to talk to him too. So, I might just ask Krexos. Let's see. So, the main study that I'm citing, and the reason that, actually, we'll go back for a second, the reason that I want to have an efficiency higher than 18% is because one of the studies done at the University of Wisconsin-Madison, what they did is they used waste energy to break water bonds and use the hydrogen as energy. And they've only done that to about an 18% efficiency, and they've not used a lithium-ion battery. The reason I want to use a lithium-ion battery is because I can actually use the energy and store it, which is most important. However, there's totally messed this up. So what they specifically did to break those bonds is they used nanocrystals composed of zinc oxide and barium titanate. That's not good. When they were placed in the water, they were also with ultrasonic vibration, and that was the catalyst, and it caused the bonds to break. So what it is, the project is kind of like an advanced form of electrolysis. And what it does is it puts currents through different types of things, in this case water, and it breaks the bond so I can actually use the hydrogen bond. So here's kind of like the pencils in the water, it's kind of like the second grade version of it, just super easy. And then I just put a giant thunderbolt in water for kicks and giggles. And then there's a definition of electrolysis. And then up there is just kind of like the chemistry of it, where you have a water molecule, like hydroxy ion, and you break away the hydrogen ion. So one of the main issues is that hydrogen is kind of sassy and it likes to bond to anything it possibly can. So the most difficult part would be actually breaking those ions and then holding on to them and storing them. And then also the cool thing is that the electricity still can be used to make the nanocrystal fiber can be solar power. So that's like another environmental aspect that I actually found by mistake, so it might work really well. So my protocol is kind of disgusting looking, so I'll just explain it. So specifically for this project, what I would need is the lithium-ion battery and the nanocrystal. The cool thing about a lithium-ion battery is that they're super cheap and really effective. And you can actually build one. So I think I might just go with the kit, because I think that's the least important part. Not exactly building the lithium-ion battery. What I'm building or putting together is the nanocrystals and things to actually pulsate with water so I get the hydrogen molecules on it. And then finding the most effective way to store that hydrogen. And then, so I think I'm going to try it in different scales. I work on small scale first, kind of just using like a beaker and a small battery, and then can I make it larger and more effective. So then a really cool impact of the entire thing would be it can kind of change, not every source of energy, but a lot of it. There are some entire things that run on lithium-ion batteries, especially with hydrogen power. If you have guys who are the smart house in the museum science industry, anybody? Okay, yeah. But what the smart house does is they run a few things on the lithium-ion battery. That once they featured a car in there that was completely run on a lithium-ion battery, powered by electricity. Then a few things in that house are run by hydrogen power. So that's kind of cool. These are just my sources. I have a few more, but these are specific to the project. I have a few specifically for something like this, when breaking the hydrogen. I have a few few on the chemistry of it, and then I have something specifically on like the environmental impact of using the lithium-ion battery. So I have like maybe 12 sources total. So I'm kind of excited about the outcomes of what the path is, because I would like to have a stronger understanding of chemistry and electrolysis. Biomedical engineering and chemical engineering is an interest I have for collegio. And then the second outcome would be a better, more abstract ideas for alternative energy. That's a really big issue that a lot of people address in science fair. And I think we can have so many different ways, and which way is the easiest, which way is the cheapest, and which way is just coolest that they can pick. And then, so I'd also like to learn the process of using the lithium-ion battery, because they can be used for a lot of different things. It can be powered by multiple different things. And one really cool thing is that they can actually store energy really well. So I think that's why I'm specifically interested to use it for this project. So for my investigation outcomes, my first one is having an alternate to non-environmentally sound forms of energy. I would say this is environmentally sound or perfect, however, it's much better than what we're using today. So it'd be a best alternative to coal or whatever. Even those, even cars that run on electricity, the things that the gas stations that they go to that use electricity, they use a lot of energy. So can they just store the energy in lithium-ion battery and create from hydrogen gas? It'd be way easier. I don't know if it's in Switzerland or somewhere weird. They have like a car that runs on hydrogen, and like they have a gas station that's straight up hydrogen. It's actually really cool. The thing is like the gas pump is just like air. It's really hilarious. And then the second one is have something more effective than sources of alternative energy we have now. Different types of alternative energy besides oil and coal and all things we used to use would be like sugarcane, ethanol, other types of natural gases that are, again, not as friendly to the environment or not as effective to the environment. So those are some of the sources. So then the third one would be creating a more cost-effective form of energy that can be available to not fully developed countries, but developing countries and third world countries. So America does use a lot of natural gases and coal. However, we don't use as much as. Actually, like we're looking weird at my face. I'm like, no, this is the fact works. And then the status of my project is conditional because it's an engineering design. There's always the time where let me go back and try to fix something as opposed to just working on something or something specific. And then I kind of want to have a better grasp on just the chemistry of it. I mean, I took chemistry sophomore year, so I don't remember sophomore year. So, that's very kind of big on it. But that's just what I really would like to do. And then for my timeline, it's back here somewhere. I think my timeline is not what it's called. Yeah. So, as I've talked about ordering materials, I just have to compile a few things of what I would like to use. I might just try to create my own animal crystals, who knows. And, I know, but still. I'd like to continue, like, in this time between, like, when I order things and when I actually do the project. I guess chemistry is you can't know everything, so it's going to be a continuous learning process, which I think is kind of cool. And I think I could maybe start in winter break with a small scale, and then maybe by early February finish with a larger scale type of project, and maybe do another small one in between that, because I can do maybe 2 at a time, because I know exactly what would be happening. So, yeah. That's everything. I kind of like this font, I don't know why, but okay. You can totally ask me questions and then